All right, thanks for joining us for this session on Pion, solving production RTC problems with composable open source Go libraries. Sean DuBois will be presenting for us here in just a moment. Just want to give a couple quick tips to our viewers. Sean is sharing his screen. You can double click on that screen share to maximize it in your screen, and then if you need to further, enter full screen mode in your browser. If you have any questions during the session, anytime, just go ahead and put them in the session chat, and we'll make sure that Sean sees them by the end. So with that, Sean, thanks a lot for joining us today. Looking forward to this presentation. The stage is yours.
Awesome. Thanks for having me. So yeah, I'm Sean. I work on Pion. And first off, I want to thank everyone that has helped the project. Even though I get to come up here today and talk about it, a lot of other people have come into actually making this, both the WebRTC for the Curious and the Pion project. It's all open source. There's no company backing all of this. It's all individual contributors. So I want to give a big thank you to everyone. So if you're watching this talk, like what I want to talk about is the two main things that I've been focused on in the WebRTC space, which is I want to go beyond the standard use cases. Some of the things that have been really interesting to me lately is kind of the cloud gaming. There's some companies that use Pion to do that. There's some companies that use Pion for teleoperation, so for censorship circumvention, protocol bridging. Like these are all things that are using WebRTC and are getting bigger and bigger in the WebRTC space. And I've been doing this for about 3 years now. And what has kind of been motivating me is this idea that I think I want to focus more on than just the software. There's things that we've kind of taken for granted. So there's the community aspect. A lot of what I'm trying to do is build a community to help each other and support each other and explain these questions that people have about WebRTC. The next is like the education part. So I'm working on a book called WebRTC for the Curious that's completely free. It's licensed so you can copy it and use it in any way. I want to free up. There's a lot of misinformation about what WebRTC is and how it works, and I want to make it more accessible to people. And then the last is Pion itself. That was the first project I started, and it's a WebRTC implementation with no assumptions. And this is my perspective into it and like what these 4 points really drive the project. I believe developers are smart and they need to be empowered. There's a lot of WebRTC implementations out there that is just a big code base and you drop it and you don't really have a lot of knobs. Like the idea is that the user isn't smart enough to understand what WebRTC is and how it works, but I want to give you that power. I want to allow you to dive into it and understand what's going on and empower you to go learn more. Like that's when like you can build something really awesome. Like I don't want to just give you a blob and then that's all you get. And the other thing I found is developers find happiness from owning their projects. A lot of times, like people want to envelop everything under their brand, and it's really important to me. And I talk about at the end that people own these projects under their own brand. So like as I try to put more and more outside of Pion, and then the more users, the better. I try to be as friendly as possible to users that don't feel comfortable sharing. I have a lot of private conversations with people, and I encourage people to, I start private, channels on our Slack so they can talk to each other. I want people to feel as comfortable as possible because I found that instead of just rejecting things right out, like people get more and more comfortable when they bring into their own. And then also I want to involve everyone in the project. So with Pion, if you make one PR, you actually get added to the project as a contributor. Your name shows up in the README. You have access to open PRs and everything. And like there's not like a inner circle of Pion developers. Everyone has access. I need to have something merge into master. I need one approval from someone else. And for someone that's brand new to the project, they need one approval. Like there's no tiered steps. And the two projects we'll talk today, the first is WebRTC for the Curious. So you can if you just Google WebRTC for the Curious, it'll turn up, or it's webrtcforthecurious.com. It's a book on how WebRTC actually works. So this isn't just, set remote description, create offer, things like that. This is like actually dives into how the protocols work, how ICE, how DTLS works, the different things you expect from RTP. And then after that, we have the history of WebRTC. So I have one interview I have right now is with Ron Fredericks, one of the authors of RTP. And I'm working on interviews with people that were involved with the IETF standardization of WebRTC. I have another interview that I'm going to post soon with the author of SCTP. And this stuff is really important to understand, like, what was the motivations for people going into this technology? It helps get you in the mind space. It's very easy to kind of write off, like, oh, this technology doesn't work for my use case, or I don't understand this. And a lot of times you have to get in that headspace and understand where things are coming from to use them properly. And the last is the WebRTC in practice. I want to help people. I spend a lot of my time helping people debug, and I want to, instead of having me repeat the same things over and over again, I want to make it so you can just go to this website and learn, and also other people can contribute. The entire thing is on GitHub, so you can make a PR, and all of a sudden, whatever you've wrote shows right up on the website. And the other is Pion. So that was the original project, and what it is a collection of Go RTC libraries. So we have the first one is the actual Pure Connection API, or what people call WebRTC. So you can run some code on your server, on your desktop, on your mobile that's just written in Go, and you can call create offer, you can call add track, all the things that you expect. And then where it starts to diverge and offer new things is the fact that the user controls the media pipeline. So you have two options. You could call get user media in Go, and it would have everything you expect. The congestion control, it would capture your webcam, all those things you expect. Or you can easily bring your own video buffers. Like, you could read some H.264 off the disk. You could connect to an RTMP server. I want to give you the flexibility to build those interesting things. And the next thing is the setting engine. We allow you to do a bunch of custom things, like control the ranges of ports you listen on, or enable MDNS, things like that give you the customization you need. And the last one is the interceptors. So instead of putting the congestion control and NACs and all of that deep RTC stuff inside the WebRTC implementation, it's actually configurable at the surface level. So when you start Pion by default, there's none of that. But then you can opt into what you want. You can opt in to have NACs, you can opt in to have this, because it's important to give people that flexibility and to prototype and decide what's best for their application. And then the two other projects, we have Turn as an API. So instead of running a Turn server and then you put in, the IP and port of your database, instead, it's just a callback that gets fired, and you choose where to get that data from. So, you could hard code your credentials into memory, or maybe you could put them in a database that isn't supported. And it's all about giving you the flexibility. We had just a project that came out called Scrigo, where they actually put their HTTP server and their Turn server in the same process. And I think that's really powerful for small applications that they just want to control their deploys. They want to wire things up that make sense to them. And the last one is Ion. Ion is a cluster-based system for building RTC. So instead of deploying one monolithic server, you have a bunch of little containers that all do very specific things. So you could start up just an Ion cluster that only has SFUs, or you could start up an Ion cluster that has SFUs and live instances. And so you could have SIP input into the SFU. It's all about giving you that flexibility to build the system you need. And the other thing is you can build your own clusters. So we have companies that are running Ion, but then they have their own proprietary cluster where they have one instance that they wrote for themselves, and then they use the rest of the pre-baked instances. And that's really powerful, because that means that you're not stuck running an old version of Ion. If you go and modify an open source project, either you have to merge all the time, or you have to figure out, do I contribute upstream, and does it make sense with the project? We try to design Ion in a way where it's easy to use to build what you want, but then it's also easy to stay in track with the project. So we're going to mostly talk about what if you're building something interesting, that we kind of talked about those non-standard use cases. What is Pion? What are we doing with it to make it a compelling choice? So one of the important things is it's designed for all skill levels. So if you already have used WebRTC in the browser, this is an API you already know, you can copy some code, and all of a sudden you do create offer, create answer, and you're off, and it's working. The second part is Go makes it really easy to build stuff. Talking to companies, I think the hardest thing they're doing is hiring RTC developers. And a lot of that comes from the difficulty of the languages that a lot of stuff is written into. And Go is designed to get out of your way. It's memory safe. It's easy to code and deploy, like you get static binaries. And even the author of Go, like he designed it with that intent. He described that a lot of the employees that they were hiring were typically fairly young, fresh out of school, and they wanted to give them a language that it had to be easy for them to understand and easy to adopt. So Go is designed that you can bring someone into your existing complicated code base and they can contribute quickly. And then what we referenced before was the WebRTC for the curious. So as you learn and use Pion more and more, you'll think, oh, I don't really understand how ICE works. And then we have this companion piece that is WebRTC for the curious. So you can go look and learn deeper how this technology works. Because you're going to hit bugs eventually. You're going to hit things where you just don't understand what's going on. And we want to give you that information. And then when you start to build out your application, you'll want to deploy to custom networks, or you'll just have other things. And that's where you'll want to, all of a sudden you'll realize, oh, like maybe the certain part of Pion doesn't work for you. And what we did is we actually put each one of our modules in a separate repository, and you can rip out and use your own. So let's say like you don't like Pion's DTLS implementation. You could go use a different one. Like as long as you implement the same public API, you can easily flip out. It's even simpler than like, let's say you have a C library, you have to go and edit the package config and other stuff like that. It's way simpler than that. Like Go is built in to easily fork and change the location of the repositories. And then the other one is like when people hear Go, they assume, oh, this is just for servers. But here's all the places that people are using Pion today. So we have people that are doing servers, and they're doing Windows, Linux, FreeBSD, and it's all these platforms, x86, ARM. And the other nice thing is it's a static binary. So you don't need to have Go on the server. You could deploy a server that's completely empty, nothing on it, and you build your binary on your desktop, and then you ship it off to the server. So I'm running a Mac locally. I can build a binary for Linux and ship it off, and I don't need any kind of complicated cross-compilation environment. And then the next is mobile. So we have a company called Strive that they have SDKs that are for all of these mobile platforms, and they use Pion behind it. And the idea is that Go, when you build these static binaries, you can also generate a shared object and a header file. So I can, create my function that's like connect to my signaling server and start a peer connection. And then you can link to that from Android, iOS, or anything else you want. And I'm also seeing more usage on the smallish platforms. So not true embedded, but a lot of these security cameras and embedded devices that you see, like they're running BusyBox, they're running Linux on them, and they've got, flash memory that's got, 64 megabytes of space. Someone is actually running Go on that camera, and they're pulling the video buffers and then like connecting up from WebRTC, and we'll share that later. And then the really cool one is that actually you can write your code in Go, and then you can deploy it to JavaScript. So with WASM, you can use the Pion API, so you get that type safety, you get the easy hackability of Go, but then it'll swap out and use the browser's implementation of WebRTC once you deploy it. So people ask me about the features. If my rule of thumb is if the browser has it, we want to have it as well. So we have stun, we have turn, we have data channels, we have simulcast, we have congestion control, you can do FAC and MAC, we have the get stats API. If we're missing something, it's just we haven't had the time to do it yet. We've also taken a greater look at performance this year. So I wrote up this project called RTSP Bench, and if you care about performance, you can download this, and it comes with a simple server, and it comes with a simple client. And what I did is I deployed an M42X large, and here's what it looks like I ran around 14,000 peer connections, and I saw around like 25% CPU usage. So you can go use whatever RTSP feed you want and see like how does Pion perform on my servers. And then we talk about that expert level. We have these Pion specific APIs. So you can do like things like run ICE Lite, set the UDP port range, maybe only listen on one interface. ICE candidate selection rules, like maybe you always want to use like stun, or you only want to use host in certain rules. Like, so instead of having to do STP munging, we give you an easier typed API so you can do these things. And then the other one is the interceptors. So this is a new in V3, but the idea is that for each peer connection, you get a list of callbacks that are fired for inbound RTP packets and outbound RTP packets. So for each RTP packet, you could apply FEC, or maybe you could, generate transport-wide congestion controls. You could also bring like your own algorithms. So because this is a public API, you don't just have to use the implementations we bring. Like, you get greater insight into the congestion control algorithm that Pion uses, but you can also bring your own. You can choose the latency and loss trade-offs that are important to you. So using that API, I want to talk about like what do I see people building, and drop some code examples to kind of help you visualize like what your code would look like. So the most popular one is the SFU cases. And so since Pion is a Go native implementation of the peer connection API, you spin up a peer connection in the browser and you spin up a peer connection locally, and that's it. So if you were having two people that you wanted to talk through the SFU, you would have two peer connections running in your Go server, and those peer connections would then just be copying video buffers between each other. And that's it. Pion has full unified plan. It has renegotiation. So you can, as new tracks come and go, you can add, remove track locally and renegotiate, and it all just works. And then you decide your congestion control as well. So when working with one person, they had very, very simple clients they wanted to run remotely that only supported, responding to REM. And so like we were able to switch and like decide on the fly, like what does this client use? And that flexibility was super important when hitting those custom use cases. So what about MCUs? So the truth is, Go, the media libraries in Go, they're just not going to happen. Like, you're going to be using assembly and you're going to be using C. We're seeing some use cases in Rust, but I haven't done it myself. Calling C from Go is pretty painless. So here we're calling a C API, GStreamer receive push buffer, and we're passing in a buffer. So the second argument is the buffer, and the third argument is the length, and that's all it takes. So I've seen people use FFmpeg, I've seen people use GStreamer, I've seen them use libvpx, libretro. Like, there's a lot of interesting things I've seen them do here. So don't think if a certain library isn't available in Go that you're stuck. Like, you can use it still. So here's a cloud gaming use case, and this is actually a diagram that was done by the Cloud Retro project, that they are making old NES games available via WebRTC. So what they do is they run a game emulator in memory called libretro, and they will take WebRTC input streams, which is the data channel messages, and they'll send them into the game emulator, and then out of the game emulator, they'll pull the image frames and the audio buffers, so you can play a game remotely. And I have a fun little demo of it later. And here's a little simple load tester. So this comes from the RTSP bench, but this is all it is. So inside a for loop, I'm creating 10 peer connections, and that's it. So the remote server is pushing video at me, and I create a peer connection, I add a transceiver, I'm willing to accept one remote video track, I create the offer, and I post my offer, and they respond with an answer. And we set the remote description, and we're done. So with this, you can spin up thousands of peer connections, and because you decide what you do with the video buffers, we're not going to decode them. So we're able to spin up, hundreds, well, I guess 15,000 peer connections on one server without a problem, because we're not doing the decoding, we're just like exchanging the video buffers. But if you did want to do the decoding and analyze the video, you could do that as well. And then the next one is the teleoperation. So we have people that want to control remote drones, they want to do security cameras and stuff like that. What I've realized more and more is how powerful SCTP is. And so the SCTP, it's not just like a simple datagram-based protocol. Let's say like you want to send like a large image, but you want to say like, oh, if part of the image is corrupted, I want to skip it. SCTP has all these powerful things in it that I think hasn't been published well enough. There's alternative protocols that have been proposed to SCTP, but they're dramatically a subset of what SCTP offers, and it's kind of just been an education issue. Another one is just the absolute frustration that corporate networks are. So we have some that are TCP or TLS only, some that require certain port ranges, some that require proxies. WebRTC is really nice in that regard because with ICE, you try all these different network routes and find the best one possible. And here's an easy one that I thought was really, really fun. Was someone wrote up a protocol bridge that just uses FFmpeg via standard out. So using FFmpeg, they can exec a command. So like an RTMP, they can connect to an RTMP client, or they can, pull RTSP, and then they'll send the H.264 frames out to standard out, and they'll copy them into Pion. So that's all this is. They launch FFmpeg, they connect whatever they want, and then they make it available via WebRTC. So in these 15 lines of Go, like this is how you could write an RTMP to WebRTC bridge, and that's all you need. And then next I want to show like what people are actually building with Pion today. So this is an open source project, NS Remote, and what they do is they actually make it so you can play your Nintendo Switch remotely. So they connected a Nintendo Switch to an HDMI, and they send those video frames over the network, and you put on your Oculus, and now you're able to play Animal Crossing, whatever games you want, live. Like you're actually dropped in the game, and those video frames are being sent over the network via WebRTC. So it's kind of like that same cloud gaming use case, except you're playing with a device that's right in your hands. Like I think it'll be exciting to see we can bring all these existing games and all these existing devices and software like into the VR space. Here's the Cloud Retro. So being able to play a NES game remotely. So this is running a NES emulator on a remote instance, and it's just shipping the frames back and forth. And I've been playing this a lot, and it's just a huge amount of fun because the cool thing is I can share a link with someone, and then both of us can start playing together. Like they're player one, I'm player two. It kind of recreates that sitting on the couch and playing an NES game experience. Nico is a project to run a browser that's remote, and you can share the video frames with everyone. So like 10 people could share one Chromium instance remotely, and you could watch a movie together, or you could keep up like a heavy web page like Slack without having it tax your local computer. And then another cool one that I've been using recently is you can use this to record conference calls. So I will load up my Google Hangouts, or I'll load up my Zoom call in this, and then this is where I record the thing. So it's basically a platform agnostic way that I can record conference calls, and I'll send them out via RTMP to Twitch or whatever provider you want to use. So it's a great way to you're basically rebroadcasting your browser. And here's the teleoperation case. So TeleGo gives you the ability to control a Telo just in your web browser. So you drop the operations in, and then in the bottom left corner is the actual video feed of what's happening. And this is when you send the data channels to control things, and you're using the video feed to actually watch what's happening. ASCII shows you can use Pion anywhere. So if someone wrote a WebRTC client that's completely runs in the terminal and it's all ASCII, so they can jump in a call and talk to someone else. Like I'm in my browser, the other person is just in their terminal, and we can talk to each other. It just uses the C libraries for libvpx, and just kind of shows the use case that you can use this anywhere. Strive CDN. What is so exciting about this company is how they're using the Pion to power so many SDKs. So they are able to do, in the browser, they're able to do set-top boxes, they're able to do phones, they're able to do servers. And the idea is that if instead of having 10 people in the same network download a video file themselves, they connect to the CDN and download it once, and they share it all with each other via data channels. Then we talked about the protocol bridges. So here we have an embedded camera that's running Pion and then making that video available via WebRTC. You're kind of breathing new life into all of these existing RTSP devices, so they don't have to launch VLC or something else to watch those feeds. And then you've got all these great NAT traversal use cases. So SSH peer-to-peer makes it so instead of having to maintain a jump box to go into these servers, like you can just connect directly to them. So in the same case that me and you can have a conference call over the internet, you can connect directly to your server without a problem. RTC tunnel accomplishes the same thing except for TCP services. So I can use Redis or access an SSH service directly from my browser. Snowflake is, how do I use Tor if I can't download the client today? Tor makes WebRTC available. Tor makes the network available via WebRTC data channels so that I don't have to download a whole client and have to worry about it being blocked. Like as long as I have a browser with a working WebRTC implementation, I can connect to anything in the world. Then you have something like Web Wormhole. So there was a Python implementation that was only, you could share a file Python to Python process. Web Wormhole is that, except it works in the browser as well. So I can share a file from a Go process on my desktop to another computer in my house that's using just my browser. It works on mobile, it works on all these other platforms, which is super exciting. And here's a visualization of that Ion project we were talking before, where everything is container-based. So I can have my SFUs, my MCUs, my RTMP gateways. You can have all these custom things sitting in their own containers. So if you're looking at this, Pion, I think, just isn't great to use and build your own things, but we'd also love to help you. We'd also love your help. It's a fun challenge where you get to pick your own goals. If you want to learn something deep about WebRTC, you can join the Pion Slack and get involved and help us build things, and you can learn a lot for yourself. I think we've had multiple companies that use Pion to build their products. We've had multiple people that have actually started their careers because they started contributing when they were in college and they were referred to these companies that were using Pion. So I encourage you to get involved. Like, this is a great place. Like, if you're stuck looking for a job right now, this is a good chance to brush up on some skills. Or if you're at work and you want to change up what you're working on, like, we'd love to have you. And whatever your motivation is, you should reach out. So those are the URLs that, if you're interested, is the Pion. We have our GitHub presence. The Slack, we're sitting at, I'm in there 24/7 talking to people, and people aren't just talking about their Pion projects, but they're also talking about like other things they're building and what they're excited about. And I encourage that. Like, it doesn't just have to be about Pion. Like, as long as you're building interesting things and pushing the technology forward and you're a good member of the community, we'd love to have you. So thanks for listening, and I hope to see you there.